Hi everybody, I am back. It's Brian and we are here with lesson number 9, which is all about systems, assemblies, components, and joints. What we're looking at is kind of what we're going to fabricate together here during this demo. And I think this will start to tie everything that we've done up to this point together to help you understand how you can build a moving system within the context of Fusion 360. And I know this has been a long path to get here, but we really have to understand the basics of Fusion before we can get to this kind of advanced stage. What is so cool about the thing we're looking at is this is made up of individual components that are linked together with joints to create a multifunctional system. And to demo that, I can simply grab any element in here, click, and I can start to manipulate the whole system, right? So this now I've defined essentially some physics by which this system is bound, right? So I can't rotate it any further than that. That's its most fully open position. And I can't rotate it any further than that. That's its most fully closed position, but I can affect change, and this thing operates as a system. And we're going to start with what I drew in part 1 and part 2 of this demo, the bone bar and the DALI bar, if you will. We're going to use those to create subcomponents or sub-assemblies, and we're going to build those together to create this fully functional piece. So let's hop in and get started. I just want to kind of show you here on this system, maybe to give you a little context. This thing is created by this multi-linkage demo that I put together to get to this stage. There's 2 of those, right? So if I hover over that, you'll see there's number 1 there at the bottom, and there's number 2 at the top. So there's 2 of those. And there's 2 dowels, right? There's 1 dowel, 2 dowels. Those are just simple. I didn't even go over how to do that. That's just an extruded circle at the same diameter as the holes, right? So there's my 2 dowels, and there are those 2 multi-linkage demos. But these multi-linkage demo pieces are actually made up of even smaller components. And so we can start to drill down into this. So I'm going to open up one of these here. There you go. And you can see this is made up of a linkage demo, and there's 3 of them. So there's one set, right? It's this set here at the first thing, right? You can see it kind of graying out there. The second set, which is connected to that, and the third set, which is connected to that. And if I expand each of those is made up of a bone bar and a DALI bar. And in between each kind of hierarchical jump, there are joints, and the joints are defining the behavior of how these things move, right? And you can kind of see the joints are scripted here. This is giving me the maximum rotation of this joint here, 82 degrees. And you can see each one of these is confined by 1 revolution or revolute joint, which allows it to spin around kind of a central axis with some definitions, right? And that happens at each one of these sets. Theoretically, you could do all of this nesting within 1 drawing. I highly discourage you from doing that because the drawing gets so complicated, it's really hard for you to go back and edit those things. So what I've done is I've done these individual drawings all along. We started with the bone bar, we started with the DALI bar, we bring those in, they form the base hierarchy, we create a linkage that's those 2 in a joint, we save that, that's its own file. Then we're going to open that up in a new file we call multi-linkage, and that's going to be made up of 3 of those, right, or 5 of those if you wanted this whole system to continue, right? And then I'm going to save that. That's going to form 1 backbone, and then I'm going to bring them into this larger assembly, which I'm calling system, right? I know they're horrible names. They're not very descriptive titles, but hopefully you get the understanding. So I have these independent components. They are then linked, which are then linked, which are then linked. The nice thing about this is within this nesting structure, I can go back to the DALI bar file and I can make a change. I can change the geometry of that, and that And then if I reopen this system demo file, that change will kind of cascade through all of those, and it'll give me a little notification up here. There'll be a little like arrow that says this is, there's a newer version of DALL-E Bar. Do you want to update it? And I can click yes, and it will go back and get that original file and then cascade that effect on all of those. So it's much easier to go back and change and modify your system by modifying one component. So let's go ahead and get started with this. It is a little complicated, so just try to stay with me as we go along each step. Actually, I'm going to rephrase that. I don't think it's actually all that complicated. I think you just have to think through a process to arrive at where we are. This is like construction, and I think that's kind of the fun thing about it is once you've designed this now is all about building it, and you're building it virtually. So if you were making this in the wood shop, right, you'd have to cut all of these pieces, or you'd have to laser cut all these pieces in the laser cutter, and you'd have to connect them with dowels. So you'd have to like cut each of these dowels to the right length. Essentially, you're doing that exact same thing, but you're doing it by adding those components into your drawing here in Fusion. All right, so I'm going to leave this open so we can always go back and look at this if we need to, but let's go ahead and get started. So I'm going to open up a new file. And so hopefully at this stage, what you've done is you've drawn the demo bar, the DALL-E bar, and the bone bar. Because if you've done that, it'll be easier for you to bring those in and follow along. The other thing you could do if you really wanted to before you get to the system is draw a quick dowel, which is just a circle started at the origin point with a diameter of 10 and is like, I think I drew mine at 50 millimeters long, but they could be really any length. You just need those three files. Your DALL-E bar, or whatever you want to call it, doesn't have to have that exact shape. Again, the important thing is the spacing of those holes. So I've opened up a new file. Here, before I can start to work with, Fusion calls them components. SolidWorks calls them assemblies. But before I bring in any of those referenced files, I actually have to save this file before I do anything else. So we just need to give this a title. Lesson 9, first tier. Is what I'm going to call it. I don't know if that makes sense to me in the moment, but maybe it won't later. Okay, and so what I'm going to do here is I've saved it, and now what I'm going to do is I'm going to bring in those two components. So I'm going to go to my data panel. I'm going to find them here in my list of all these things I've drawn for you. There they are. And so there's the bone bar. I'm going to right click on top of that, and I'm going to say Insert into Current Design. If you haven't saved this, you will get an error that says you need to save the file first. What it's saying is it needs you to create a title for the drawing you're working in. All right, you drop it in, it's going to ask for a position. I'm just going to leave it where it is, so I'm going to click OK. And then while I still have my data panel open, I'm going to click on my DALL-E bar, right click, and say Insert into Current Design. And there it is on top. I'm going to just grab this little arrow and lift it up a little bit above and click OK. So at this point, I'm going to close my data panel so I have more drawing screen available. And you'll note what happens now is I can take these guys and I can move this around. And similarly, I can move this bone bar around. There is no relationship between these two. What I need to do is I need to start creating the physics by which these things will relate to one another. And we do that through a process called joints. Now, I'm going to do like a quick tip thing where I explain the different joints and try to do simple examples of those. But I really wanted to get this video out so you can start to understand system design before we have more of a conversation about how this might relate to your projects. So anyway, I'll go into the different types of joints in a little bit more detail in that quick tip. So stay tuned for that coming up here in a little bit. But the first thing I would do is I want to create a joint between these two. So up here under Assemble, if we click Assemble, there's joints, there's new components. So if you were going to do that nesting thing here, you could do that here, and I could click New Component, and I can grab these two things and add them to that new component. But I'm not going to do that here. I'm going to to save this file, and this is going to be my component, and then I'll open another file and do the same thing to the next level up. So I'm going to create a joint. The joint icon is right here. It looks like two parts of a hinge, so that's giving you some understanding of how this works. So if I click that, this pops up. It's going to say some components have moved. I've moved these things out of their existing space. Do you want to continue, or do you want to capture the position? If you click continue, they're both going to go back so that these both share the origin point, and they're going to be on top of each other, and they're going to be hard to deal with. So I'm just going to simply click capture position, and it's going to capture their existing position where they are. Okay, now I need to decide what type of joint I'm going to use to define these two. Essentially what I want is I want the center hole on both of these things to be tied together and them to revolve freely around that center hole. And so that type of motion is what's called a revolute joint. Now, these are all your joint types. There's a rigid joint. I would highly discourage you from using that. That kind of locks things in place and it will prevent them from moving. So be careful about using rigid joints. There's revolute joints, which allows it to go around, it essentially ties these two things together around a center axis. There's a slider joint, which is it constrains the motion along an axis. There's a cylindrical joint, which constrains the motion along a cylinder. So you could connect these two with a cylindrical joint. They can spin, but they can also slide up and down on that concentric cylinder. In this case, I don't want them to be able to slide up and down. I want them to kind of be tied together and not be able to be split apart. So that's why the revolute joint for me is a better option. Pin slot, it gives you a revolution and a sliding mechanism all in one. Planar, it essentially, if I wanted this piece to be fixed to my top plane, but be able to move around, not be able to move up or down, but be able to move around on the top plane, that's this planar thing. That's like if gravity was affecting it. And a ball joint, think about like a hip socket. It's the same thing. It gives you, it kind of ties two centers of spheres together, and they can it can orbit around that sphere. So those are your options. We're going to be using primarily this revolute joint to do this. So I'm first going to select my motion type, which is revolute. And then, so there's a little pop-up here. You can change this here as well. And then under position, it's asking for a mode. Do you want to do a simple attachment? Do you want to do two faces, or you want to do an edge insertion? The simple is what I want to do because it's going to lock it down to a single point, in this case, the center of those circles. So I'm going to click the button next to snap on component 1. So my component 1 is going to be my bone bar, and I'm going to zoom in, and I want this top circle. So make sure you don't select the cylinder. Make sure you select the top the top circle. So you might have to like fuss a little bit with where your mouse is. There it is. As soon as that circle, you'll see that the icon in the middle of that looks like this icon. That's what you're seeing, right? So once that's highlighted, I'm going to click. That will now be grayed out because that component now has the start of that joint. Now for component 2, you'll see that snap has been automatically selected, and I'm going to come up here and I'm going to rotate around, and I'm going to find the circle of the bottom of this surface because I want this face down here to be lined up with the top face of my bone bar. So if I choose the top circle, these things are going to be on top of one another. Fusion doesn't know enough to know that like two solid masses can't inhabit the same space. So it will actually stick those inside of one another. So that's why I want this bottom circle. Oftentimes I'll orbit around so I can actually see it, rather than have to like select through the geometry here, which I can do, right? So there it is, that's the thing I want. So it'll move those two things together, and then it will give you a quick understanding of what that revolute joint looks like, okay? So I'm gonna say, yep, sure, that looks good. Now, if I click on one of these, like I click on the dolly bar, you'll notice that these things are moving together. And again, it's because Fusion doesn't know you don't want these things moving. So what I need to do to start to enhance the motion is to ground one of these things. And so this is something I'll do at every stage, is pick one element to ground. So I am going to ground my bone bar. And so if I come over here to bone bar, if I right click, you can't see it because it's off the top, but at the top of the drop down menu will be something that says ground. And I'm going to click on ground. Do I want to capture the position, or do I want to continue? I'm actually going to continue because that's should put the bone bar back down at my origin point. So I'm going to do that. Oh, it's actually put it where it was when I created the joint. All right, but you'll notice here now under bone bar, there's this little thumbtack icon next to it. That means that that is now grounded. And you can always unground it by clicking on it and click unground, which again is off your screen. If you're looking at it, I can see it on my screen. But it's grounded, and the way I know that is because now if I grab the DALI bar, I can, if I start to move this, it will only move the DALI bar. It will not move the bone bar. Okay, so this is pretty good so far. I've now created that one joint that expresses how I want these things to move around one another, and I can spin this around like a propeller. The problem with this is that I don't want these, if I let them do this, they'll be able to cross through one another. And the physics that I'm trying to create is that there'll be another linkage attached here, and I want it so that this piece would theoretically hit that other linkage. You can do this later by doing this like interference detection thing. It's just easier at this stage to set limits for that joint. And so what I'm going to do now is I am going to come here, and let's look at a top view because that's going to give me the best view of this thing, these two guys together. So I can actually see that airspace between those, right? And there's like, it's not touching, it's not touching. Over here on my browser, we have the bone bar and the DALI bar. They are here. And then you'll notice now that there's something above this that says joints. The minute I created that first joint, there it is, right? So I'm going to open up that joints drop down. And there is that revolution joint, right? So I can hover over it. It shows me on the screen what it looks like. And there's this little icon next to it that says Edit Joint Limits. If you click on that, it will pop up this joint limits. So I want both a minimum rotation and a maximum rotation. So you can just do minimum or maximum. In this case, we want to do both. And my minimum right now is, if I step in here, I should be able to move this. There we go. 15 degrees looks good, right? And then I'm going to come down here to my maximum. And I can click this other arrow. And I want the maximum until I get to that point. Whoa, we don't want those guys to hit one another. So I think we're going to make that our maximum 145 degrees, right? Because that's getting to the point where these guys are going to intersect. So I'm going to click OK. And you'll see now that we have this limit. And what that does is now I can't rotate past that point, right? There's that limit, and it won't rotate. Oh, I have to change that minimum limit. I don't know why. That was weird. Oh, that should be 15 degrees. Here we go. So that's the tightest it will go, and that's the furthest it will go. So it locks those things into place, and that is a really good constraint for the start of this first tier of this hierarchy, right? All right, I'm going to stop the video there. There'll be a part 2 of this, part 2 of part 3, if that makes any sense. Maybe it'll be part 2A, I don't know, whatever. Where I'll build this now on top of the second part, and we'll add 3 of these together and link them together using some more joints. That one should be a little bit shorter. All right, so tune into that so you can see how that progression happens. Before you do anything else, actually before I go, I'm going to save this so that I capture this new file name with these joints all set up with their limits. All right, I'll see you in the next video.